Welcome back to 3 Inquisitive Kids. In this video, we will be talking about properties of symmetry, and this is lesson 2 of our chapter. In this series of videos, we will be going over chapter 11 of 7th grade math, and it's going to be about symmetry and isosceles triangles and perpendicular bisectors and so on. Our learning goals for today is to further explore symmetry in daily life and be able to create reflected points, symmetric figures, axes of symmetry, and so on. Here's some review from the previous lesson. If a figure is folded in half along a straight line and the parts on both sides of the line completely overlap, then the figure is called an axis symmetric figure. The line is the axis of symmetry. Mirror images are a kind of another thing. If two figures completely coincide with each other when reflected across a line or an axis, then the two figures are the mirror images of each other. So later on we will be talking about transformations, and one of those transformations would be reflection. Fold a piece of rectangular paper in half and then use a pen to draw the number 14. When you open the paper and lay it flat, you should result in this. So what is the relationship between the two 14s? Suppose a fold crease is located at line L. What is the relationship between the line segment E, E prime, and L? What is the relationship between F, F prime, and L? And what is the relationship between line segment AB and A prime, B prime, CD, and C prime, D prime? And the final question, what is the relationship between angle 1 and angle 2? What about angles 3 and 4? As you can see, both these 14s are axis symmetric figures, or you can say that they are mirror images of each other. Suppose the fold crease is located at line L. What is the relationship between line segment E and E prime, so that would be this line segment, and F and F prime, this line segment? So what are their relationship with L? Well, they are all perpendicular to L because they were reflected across this axis. Line L would be the axis that the 14 was reflected across. For number 3, AB is parallel to A prime, B prime, and CD is parallel to C prime, D prime. This is what happens when you reflect something across an axis. What is the relationship between angle 1 and angle 2? Angle 1 and angle 2. What about 3 and 4? Well, angle 1 equals angle 2, and angle 3 equals angle 4. Nothing changed except that this figure, the 14, was reflected across the L axis. Everything about it, its size, its shape, its length, its width, did not change. They are still congruent except that they are reflected. The figure below is an axis symmetric figure. This figure looks kind of like a plane. Find its axis of symmetry. So this would be its axis of symmetry, right down the middle. What is the relationship between line segment AA prime, so this would be AA prime, and the axis of symmetry? What about the line segment BB prime? Based off of what we've just learned, we know that both line segments are perpendicular to the axis of symmetry. What is the relationship between the line segment AD and line segment A1D1? What about line segments BC and B1C1? So AD and A1D1, and BC and B1C1. So AD is equal to A1D1 and BC is equal to B1C1. Because we are already given that this is a symmetric figure, both sides of the axis of symmetry are equal. What is the relationship between angle 1 and angle 2? 3 and 4. So 3 and 4. Angle 1 equals angle 2 and angle 3 equals angle 4 because they are in a symmetric figure. Based on the previous questions, what can you conclude? Conclusion. In an axis symmetric figure or two mirror images, the line segments created by reflected points or symmetric points are perpendicular bisected by the axis of symmetry, and the reflected angles are equal. So what does this mean? let's say that we have an axis of symmetry. This is one reflected point, and this is one reflected point. The line segment created by them when you connect them together is always perpendicular to the axis of symmetry. And this part is equal to this part because they have to be symmetric. So that's what it means by perpendicularly bisected. And the angles are equal on both sides. Here's some practice now. Draw triangle ABC reflected about line L. Here we have two triangle ABCs, and we want you to reflect this across line L. This is our solution. For the first one, you just have to take every point separately by itself and then reflect them across the axis of symmetry. You just do that one by one individually, and then later connect the dots to form your reflected figure. The second figure is slightly harder, but it's still the same thing. For B, you still do reflect it across the y-axis. First look at the points separately and individually by themselves, and then later connect the dots. Again, first reflect each point across the axis individually, and then connect the dots to result in your reflected figure. A paraglider is shown as quadrilateral ABCD, which is a symmetric figure. Given angle BAD equals 150 degrees, angle B equals 40 degrees, then angle BCD equals blank. Again, this is using what we learned about triangle interior angles. Because angle BAD is being bisected by the line of symmetry, one side would just equal 75. And now you're trying to find what this angle is. So 40 plus 75 equals 115. 180 minus 115 equals 65. And then you have to multiply 65 by 2 because this is a symmetric figure, and you get A. The side length of square ABCD is 4 centimeters long, and the area of the shaded part is blank. So knowing what we learned about symmetry, we can just reflect the shaded parts across line AC to result in one side that's all white and one side that's all shaded. So all you have to do is do 4 times 4 divided by 2, which gives us B. Expand your thinking. Given points A and B are on the same side of line MN, points A1 and A are symmetrical about MN. Connect A1B to AP so it intersects MN at point P. If A1B equals 5 centimeters, then AP plus BP is blank. So A1B is 5 centimeters long. AP plus BP would also equal 5 centimeters long because this line segment is equal to this line segment because of the properties of symmetry. And believe it or not, this figure or this solution of doing this problem is actually very common in engineering when, for example, you're trying to find which place is best to build a market or a railroad station in between two towns. In this case, A would be one town and B would be the other town. Village A and Village B have a drinking water problem. Both villages decided to build a well, P, on River MN to allow both villages to have access to water. In order to save money, the canal has to be as short as possible. Where should the well be built? And you have to prove your thinking. What we can first do is reflect one of these points, A or B, across MN to get A1. Then, since we know that a line segment is always the shortest distance between 2 points, we can connect A1 and B together. And that's the shortest distance between A1 and B. Now, all we have to do is plot a point right over here. So that's point P. And if we build the well over here, it would be fair for both villages A and B because they both have to walk the shortest amount and the equal amount of distance to get to the well. Given point P is any point within angle AOB, point P1 and point P are symmetrical about OA. P2 and P are symmetrical about OB. P1 and P2 intersects OA and OB at points C and D. If P1 P2 equals 10 centimeters, then the perimeter of triangle PCD is blank. Let's first highlight out what we know. We know that point P1 and point P are symmetrical about OA. So just to clarify that, we can make sure that it's perpendicularly bisected. P2 and P are symmetrical about OB. So here we have OB, and they are perpendicularly bisected. P1, P2, so P1, P2 intersects ON and OB at points C and D. If P1, P2 equals 10 centimeters, then the perimeter of PCD is blank. As you can see, all we have to do is reflect DP to this line across OB to get this line. So that's PD. And we could also reflect P1C across OA to result in the other side of triangle PCD. And so it's also 10 centimeters. Today we learned about properties of symmetry. The line segment connected by the reflected points is perpendicularly bisected by the axis of symmetry. And symmetrical segments are equal and symmetrical angles are equal. So I hope you enjoyed this video, and be sure to come back for the next lesson.